All right, people. This is lesson 7 or 3.7, part 2. You'll see the reason we broke this up into two sections. We started talking about slope and equations of lines in the first part. This part is dealing mainly with just the goal, the second, I think it's the second goal in this section, which is I can graph and write linear equations. Mostly the second part too, just writing linear equations. It's just the examples here that take a while. So, just to recap, what is slope? Well, we talked about a bunch of different things. We said slope is steepness, the steepness of a line. We said slope is rise over run. Similarly, we said steepness is the vertical change over the horizontal change. Okay, we also said this is a key thing. The formula for slope, which is m equals y2 minus y1 over x2 minus x1. And it really does encompass the idea of vertical change, which is the y's, over the horizontal change, which would be the x's. Same thing with rise over run. We're going to actually use this formula today, for the most part, when we're doing some equations. So first of all, something that's in your notes is writing equations of lines. So given the following information, or the following, explain how to write the equation of a line in slope-intercept form. So there's a couple different things you got to know here, and I'm going to type these out. But if you're given the slope and the y-intercept, this is the best of all worlds, because you can just plug into slope-intercept form, and I will make this smaller. For m and b, y equals mx plus b, that would be the slope and the y-intercept. You can just plug them right into that equation, and you're good to go there. Now, I hope to make this smaller if my laptop cooperates with me here. Alright, well, I'm having technical difficulties here, so I'm just going to write it in there. So hopefully it'll fit. Hopefully you can read my writing on this. So I noted before, if you have the slope and the y-intercept, just plug in into slope-intercept form, which is y equals mx plus b. Oh my goodness. For m and b. Because m is the slope and b is the y-intercept. So that should be an easy one. Now, if you're given the slope and a point on a line, I would use point-slope form. So plug into point-slope form, which would be y minus y1, stop it, equals m times x minus x1. I said stop it. Sorry. All right. And we're going to plug in for the y1, the x1 and the y1, and then the m. So that's the slope, and then the point would be the x1 and the y1. And then use inverse operations to change it to slope-intercept form. So we're going to use inverse operations then just to get it into slope-intercept form. You might need to use the distributive property too. Now, if you have 2 points on the line, you first need to find the slope. No matter what, you need to find the slope. So use the slope formula. Plug slope and 1 point into slope or point slope form. And that's that y minus y1 equals m times x minus x1. And then again, change it back to slope-intercept form. Now, for this one, it's also interesting. For both the slope and the point, or these two last ones, you wouldn't have to use point slope form if you didn't want to. What you really could do, and I'll maybe show you one example of each, you could plug them in, plug the slope into slope-intercept form, and then plug in that point that you have in for the x and the y, and then use that to solve for b. So then once you solve for b, you have your m and you have your b that you can put back into slope-intercept form. And I'll show you how to do that as well. But usually you use point slope form if you can. But I think I'll do one of each. So, examples, write an equation in slope-intercept form for each of the following situations, then graph each line. On here, I don't have graph paper, so I'm not going to graph them. But if you do have graph paper, that'd be great practice for graphing. So, so the first one, we just have slope. So m equals -4. And the y-intercept, so b equals 1. Plug it in for y equals mx plus b. We can do y equals -4x plus 1. That one's an easy one. All right, number 2 is actually one of the ones I was going to show you. I'm going to show you the way that's up here first. We have the slope and a point. So we're going to plug in, this would be m, this would be x1, y1. So we're going to do y. Well, we're going to erase that, make it look better. I'll use blue now. We're going to use y minus -7 equals -1/2 times x minus 3. Whoops. Now we just got to change it into slope-intercept form. So we change this to addition because this is plus a positive. We'll do some distributing here. So we'll have y plus 7 equals -1/2 x plus 3 times 1/2, which would be 3/2. Then we subtract both sides by 7, doing the inverse operations here. So it'd be 1/2 minus 7, which would be -5/2. We have y equals -1/2 x plus, I think it's -5 1/2, 5.5. Okay, so there's our equation in slope-intercept form. Because it says to write them in slope-intercept form. I'm gonna actually skip to number 4 for this one because you get the slope and you get the point again, but I'm gonna do it the other way. So I'm gonna use y equals mx plus b. So if this is our m, this is our x, and this is our y, use slope-intercept form. I'll use a different color here. How about purple? We can plug in 6 for y equals m, so it's 0 times x, which is -5, plus b. This is actually nice because this becomes 0, so it's 6 equals 0 plus b, or 6 equals b. I know those look alike. So now we have our b, and we have our slope, which is our m of 0. So y equals 0x plus 6, or y equals just 6 would be the other way. So if y equals 6, then it's going to be a horizontal line crossing the y-axis at 6. The last one we'll do is 2 points. So again, this one you're going to have to first find the slope. The slope is m equals, let's see, y2, which would be the second y, which would be 2, minus y1, so it's 6, over x2 minus x1. So it's going to be equal to -3, or sorry, -4 over, these are both positive 4, so m equals -1. Now it's up to you what you want to do. If you want to plug it into point slope form and then do that, or if you want to plug it into the slope-intercept form and do that. Well, you have your slope. Move that on up here. So let's see. You're probably used to the first way, so I'm going to do the second way. We'll plug in either one. I'll pick this point. We'll go 2 equals -1 times 3 plus b. So this would be 2 equals -3 plus b Add 3 to both sides. B equals 5. That's great, because then we can plug them both into our equation. We have y equals negative 1x plus 5. All right, there is our equation of that line. So the equation of that line has the 2 points A and B. Goes through those 2 points and makes a straight line. All right, that was a lot of algebra there. Got a couple more examples. We'll see, well, 2 of them actually. We're at 10 minutes, so we'll try to do these quick. This is one where it's slightly different. It says, write the equation of the horizontal and the vertical lines that pass through the point -2 and -7. What can you conclude about these 2 lines? So, first of all, if you want to show on a graph what it looks like, -2 and -7, right here. So the vertical line would go right like this. Would go through the x equals -2 spot. And this one would go through the y equals -7. So really, that's exactly what those 2 lines would be. The vertical line is x equals -2. You might remember that's an undefined line because it's going up and down. That's why it's x equals something, not y equals something. This one is just y equals -7. That one goes through the y value of -7. So those are our 2 equations. And what can you conclude about them? Well, you can see there they make a perpendicular situation. So I think what we're looking for is that they are perpendicular. All right. One more example here. And I don't recall why I put a table here, but we'll go with it. So the situation is on top of the table here. It says Gracie's current wireless phone plan charges $39.95 per month for unlimited calls, but they also charge 5 cents per text message. So write an equation to represent the total monthly cost, C, for T text messages. So cost is going to be C equals something. Let's see. It's just for a month. So we're going to get that $39.95 no matter what. Let's add that at the end here. And then it says 5 cents, so 0.05 times T. 5 cents per text. So it depends on how many texts, really, for the cost. That would be our independent variable. Well, sorry, that's our dependent variable. Nope, that is our independent variable. C would be dependent on how many texts there are. Then part B, it says compare her current plan to Julia's cell phone plan. Julia's cell phone plan costs $35 per month for unlimited calls plus 10 cents per text message. So this would be for Gracie here. Julia, the cost would be 35 no matter what per month. So we'll put that at the end. And it's 10 cents, 0.1 times the number of texts. So it says if the girls read or send an average of 150 text messages each month, which plan offers the better rate? Well, why don't you go ahead and do that? Figure out which one would be the best rate after 150 text messages in a month. All right, now I'm going to do this one as well. So Gracie, the cost would be 0.05 times 150 plus 39.95. For Julia, it would be 0.1 times 150 plus 35. So 0.1 times 150 would be 15, I think. 1/10 of 150 is 15. 15 extra bucks. That's going to be $50 for the month. For Gracie, five that would be of 150 would be half of that. So that would be 750 plus 39.95, which would end up being 37.45. or sorry, 47.45. Still expensive, but it looks like Gracie's plan is the better deal. So 150 checks. All right. Maybe if it's lower, fewer checks, Julia would have a better deal. But if we're doing at least 150 checks, we're going to say that Gracie's going to be the better deal there. Now, I'd like you to answer these on your own. Figure out the error and finding the error. And then answer the closing question. It says, is it always necessary to identify both the slope and the y-intercept of a line when writing its equation? So do you always have to find the slope and the y-intercept to write an equation, or can you do something else? All right, but that is covering our goal of I can graph and write linear equations. Don't forget to self-assess yourself. We'll see you next time.